Hello, and welcome to the University of Arkansas. Today I'm going to show you how we, at the University of Arkansas's rice processing program, use our Texture Technologies TA-XT2i Plus texture analyzer. Cooked rice texture is analyzed by placing 10 cooked kernels on an aluminum plate, subjecting the kernels to a single compression test with a matching aluminum plate that was top-loaded with a 50 kilogram load cell. The top-loaded plate descends at a rate of 5 millimeters per second until the distance between the two aluminum plates is 0.3 millimeters. After holding a distance of 0.3 millimeters for 5 seconds, the load cell ascends at a rate of 0.5 millimeters per second. As you can see, the stickiness of the rice generates adhesion energy between the two plates. Firmness was calculated by the software as the maximum force required to compress the kernels. Stickiness was quantified as the adhesion energy required to ascend the aluminum plate and load cell from the cooked rice. Adhesion energy was measured as the total area under the force duration curve in Newton seconds. Individual kernel breaking force is a method to assess the quality of uncooked rice. Breaking force is used as an indication of how well the brown rice kernel will endure the milling process. A stronger kernel will remain whole through the milling process, yielding a higher quality rice. To determine the breaking force, a 3-point bending test is conducted using the texture analyzer. The top-loaded head is flat-faced, measuring 1.5 millimeters thick by 9.9 millimeters wide. The top-loaded head descends at a rate of 0.5 millimeters per second onto the kernels sitting at the bottom-loaded plate. Rice texture studies from the program and the department have been published in Cereal Chemistry, Transactions of the American Society of Agricultural Engineers, and the Journal of Texture Studies. Here are a few of those publications and their significant findings. In 2007, Saleh and Molinet published a paper in Cereal Chemistry studying the effects of the degree of milling of rice on the texture properties of cooked rice. The significant findings were that the surface lipid content, which is directly related to the degree of milling, significantly affect the milled and cooked rice textural properties. Samples in this study were milled for 20 to 50 seconds and cooked for 16 to 22 minutes. The study found that as degree of milling increased, or surface lipid content decreased, stickiness increased and firmness decreased. As you can see here, the picture in the upper left-hand corner has a greater number of non-hydrated starch granules than the picture in the lower left corner or the lower right corner. Textural studies using the texture analyzer have also been accomplished on uncooked rice using the 3-point breaking test. Sieben-Morgen and Quinn published a paper in 2005 that correlated head rice yield to the percentage of strong kernels using the breaking force. Strong kernels were defined as those with a breaking force greater than 20 newtons. The pair also went on to study the influence of drying on rice fissure formation rates, which is also reflected by mechanical strength of the 3-point break. They found that rice drying treatments produced greater variation in kernel breaking forces when compared to a control. Thank you for joining us at the University of Arkansas. Have a rice day.